Ayo squad. Today we're going to be combining the lessons from Wednesday and Thursday into one whole lesson. So if you were crushing it on Wednesday and Thursday, you'll probably also do really well today if you continue to show as much energy and as much grit as you did those last 2 days. Let's look over at our PDN. We have 2 questions for our PDN. The first one is asking us, what is this number line counting by? I see that there are 3 parts of my whole, 1, 2, 3. So I already know that that's my denominator, and each box is worth 1. So this fraction, this box is counting by, or this number line is counting by 1/3. I can shade in the parts until I get to x to figure out what fraction x is. I have 1 part shaded in, 2 parts shaded in, so the value of x is 2/3. The last question asks, can we reduce 15/60ths, knowing our divisibility rules? I see that I cannot divide by 10, even though there's a 0 in my ones place in my denominator. There is a 5 in the ones place in my numerator, 15, so I can't divide both my numerator and denominator by 10. But I can divide both my numerator and denominator by 5, so I'll divide that by 5 over 5, because there's a 0 or 5 in both the ones place of the numerator and the denominator. If I roll my 5s until I get to 15, 15 divided by 5 equals 3. If I roll my 5s until I get to 30, it looks like this. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 5, 10, 11, 12. 60 divided by 5 equals 12. So now I have this fraction 3/12. Can I simplify this fraction anymore? Because I want to put it into simplest form possible. Well, I can't divide by 5 because there's a 3 in the ones place in my numerator. I could divide my numerator by 3 because 3 rolls into 3. I also could divide my numerator by 3 because I know my 3's well enough to know that 3, 6, 9, 12. So I'm going to reduce this fraction by 3 over 3. 3 divided by 3 equals 1. 12 divided by 3, how many times can I roll my 3's till I get to 12? 3, 6, 9, 12 is 4. The fraction 15/60ths reduces to 1/4. Today we're going to be combining our knowledge of comparing fractions with like denominators and comparing fractions with like numerators. You need to recognize which one we're doing before you fill in your inequality symbol. We're going to look at 2 examples with number 1, comparing fractions with like denominators. When we compare a fraction with a like denominator, the larger the numerator, the larger the fraction. We can see here at number 1, the fraction is 1/4 and 3/4. So if I were to look at these fractions on my bar model, I would shade in 1/4 since my numerator is 1 for 1/4, and 3 of these parts for 3/4. And you can clearly see that 3/4 takes up more of the whole, so that 1/4 is less than 3/4. Again, when the denominators are the same, the larger the numerator, the larger the fraction. Knowing that, these denominators, 7/8 and 3/8, have the same denominator, 8. So I know that 7/8 is going to be greater than 3/8. I'm going to shade in my bar model just to double check and make sure. So when I do that, I'm going to shade in 7 parts for 7/8. 1, 2, 3, 4, 5, 6, 7, and 3 for 3/8. 1, 2, 3. 7/8 clearly takes up more space of my whole, and therefore it is a greater fraction. 7/8 is greater than 3/8. When we compare a fraction with the same numerator, it gets a little bit different. We're going to just look at our screen here to compare 2/4 and 2/9. We see that they have the same numerator 2. So if I were to look at the numerators here, 1/4 is filled in now. I'll fill in a 2/4. I now have 2/4 filled in. If I go and do that with 9ths, I have 1/9 right here. I need to line it up to my 9ths. There. And 2/9. We can see that if these wholes are equivalent, which they are since they take up the same amount of space, 2/9 clearly takes up less space than 4/9 because the denominator represents how many parts we have of our whole. So when you have a larger denominator, you have more and more parts. So we could say here that 2/4, is greater than 2/9. When we're looking at the next fraction, which is 4/5 compared to 4/8, we know we also have the same numerator on both of these fractions. That numerator is 4. So the greater my denominator, the smaller my fraction. Let's just fill in the bar model to see if this is true. So I'm going to fill in this bar model for my fifths. I see it would go just about to right here. And then I'll shade it in. 1, 2, 3, 4. That's about 4/5 right there. And now I'll do that same thing for 4/8. So I'll take one more eighth, and it's right there, shaded into eighths. Now I'm going to make 4 of these boxes. 1 box, 2, 3, and 4. You can see that 4/5 takes up way more of our whole than 4/8. So I can say that 4/5 is greater than 4/8. Again, my gator eats the greater. Today, the biggest key is to recognize when we have the same numerator or the same denominator.